Okay, let me give you guys some more practice. So let's say I'm standing on top of a table here. I'm going to drop a tennis ball here. It's going to fall, hit the floor, and then bounce back up here. I'm going to drop it from a height h, okay, and then it's going to fall, and then it's going to bounce back up here, and then the bounce height here is y here. So h is the height at which I'm dropping the tennis ball. It's going to hit the floor and then bounce back up here. The height that it bounces back up, we're going to call it y. Okay. Now you're told that the height of the bounce is directly proportional to the height at which the tennis ball is being dropped. So this is a given. You have to accept it. You have to take my word for it. Okay, so y here is directly proportional to h, meaning that if you drop it really high up, then the bounce height will be much higher. If you drop it from a height of 0, then there's not gonna be a bounce height. So the bounce height will be 0 as well. Okay, so you're told that y is directly proportional to h. Okay, now find the relationship between y and h, meaning that when you're told that when you're told that this thing is directly proportional to this thing, you can pretty much draw a graph. So it's going to be something like this. When you're asked to find the relationship between y and h, what you're being asked is to find out the equation. So this is y here, and this is h here. So find out the equation that connects y and h. Okay, so so the graph will look like this, or it could look like this, or it could look like this. It depends on the tennis ball, and maybe on the surface, the kind of surface the floor is. So if it's hard concrete, then it's going to bounce a lot higher. If you're on a carpet, then it won't bounce as much. Okay, well, find the relationship. So question 1 is find the relationship between y and h, and then also find out the bounce height when I drop it at 184 centimeters. And question 3, find out the height needed to produce a bounce height of only 13 centimeters. Okay, so here, hang on. So this here, let me just move the question up here. Hang on. Okay, yeah. So answer the question. So press pause and have a go. Okay, so to answer this question here, so when you're told that y is directly proportional to h, you can pretty much draw a graph. So this one here would be your h here, h is here, and this here would be your y. Okay. Now when h is at 220, so let's say 220 is here, 220. It will have a bounce height of 30 centimeters, so maybe around here. So your graph will look something like this. Okay, this here is your 30. So well, this is a straight line, so it's going to be y equals mx plus c, but c is the intercept is 0, so we can pretty much forget about c. So it boils down to y equals the gradient. X in this case would be h, okay, because this is our x-axis. So basically you need to find out the gradient here. There are two ways. You can either use a graph here. The graph, well, it's always a height, which is 30, divided by the across here, which is 220. So the gradient is really 30 divided by 220. Or if you don't have a graph, then just use this. When you're told that this is directly proportional to h, you can pretty much jump to this thing here because you know it's going to be a straight line. So hang on, let's start again here. I'm going to show you how to do it without the graph. Whenever you're told this, you know it's going to be y equals mx plus c. Well, you don't actually need the c's because it's going to go through the origin, meaning that if you drop a tennis ball of a height of 0, then you're going to have a 0 bounce height. So you know it's going to pass through the origin. Well, anyway, ignore the c. You don't need the c. So now this here is your gradient in effect. But let's just use these figures here. So let's put this into the this here will be RH. Okay, let's put this 220 into the H here, and then put this 30 here into the Y here. What we're doing now is pretty much finding out the gradient of that line. Because the gradient earlier, the line was something like this. The height is 30 divided by the cross here. That's the gradient. What we're doing now, we are pretty much finding out the gradient. But it doesn't matter. Let's carry on. Let's carry on with this. So put this into the H here. So that would be 220 m, and then put 30 into the Y. Put 30 into the Y here. So m is 30 over 220. So this here is your m. Okay. And then tidy this up. Divide top and bottom by 10. So it'd be 3 over 22. So m equals 3 over 22. So now you've got your relationship here. Find the relationship. Find the relationship between y and h. So y here equals 3. Remember, we've got our formula. We've got our gradient here. 3 over 22 h. Okay, so this is our relationship here. So now we've got this, we can easily answer question 2 and 3 as well. Find the bounce height when I drop it from a height of this. So remember, y is your bounce height. So now you've got to put 184 into the h here. So it would be y equals 3 over 22 times 184. Calculator, hang on. So I'm timesing a fraction, so it's going to get multiplied to the top. So it's 3 times 184 equals this, and then divided by 22 equals this. So y will be roughly 25. Okay, 25. So y equals 25. So question 2 here, find out the bounce height. Well, the bounce height will be 25 centimeters. Okay. And question 3 here, find out the height needed to produce a bounce height of 13 centimeters. So now remember, the y represents a bounce height. So you put the 13 into the y and work backwards to find out h. So it's just a matter of this. I'm going to get h and multiply it to the top. Okay. So I'm going to visualize it like this. 22. Okay. So now times both sides by 22. So it will be, hang on, calculator, clear it. 13 times 22 equals this, equals 22863h. Now divide by 3. Divide both sides by 3. So calculator, divide this by 3 equals this. Let's just round off to 95. Okay, 95. So h would be 95. So to answer question 3 here, find the height needed to produce a bounce height of 13 centimeters. Then I'm going to need a height of 95 centimeters. Okay.